For our embedded systems project, we made a facial recognition security system. Here is our design. We have a servo mounted to this block that we attach to the door, with the Raspberry Pi on the side, and the battery control unit for the servo. So to run this program, we have it hooked up to the TV just so we can see, but when we run it when it's attached to the door, we can do it headerless. So we come into the terminal, we go into our directory, facial recognition, and we run the program. And now when that runs, it will pull up the video camera. It just takes a few seconds. And as you can see, there's the video, and if I put my face, you might be able to see the servo, but when I put my face in, it recognizes me. And the servo moves, and after 10 seconds, then it moves back to the locked position, so that when someone comes into the door, they don't have to lock it behind them. So we have the setup with the door. John will talk a little bit more about how we set this up, but I'll now demonstrate the camera I have here on the outside of the door. So right now it's at the locked position, as you can see, and as I come in, focus, it unlocks, and now after 10 seconds you'll see it lock again. And there you go.
So this is me just talking about some of the challenges we had while we were working on this project. And as we can see, we had to actually improvise because we had issues with the knob. So we had this knob and we couldn't actually get a position where we could get it to go close fully and unlock fully. So we had to make some adjustments on that. And then this ropes just show that we were low on budget, so we just had to tie that in to make sure that we had to at least get to work. And then the other problem we had was how to capture the face, Joseph's face. We initially planned on using the Bluetooth, but then we had difficulties implementing the Bluetooth technology because of low resources. So we just came up with one that is wired. We just plugged into a USB port there. And that worked fine. And the good thing about this camera we used is that it has higher pixel. I think it's like 3 megapixel, and the Bluetooth camera we had was like 0.3 megapixel. So that was to our advantage.
All right, so I'm just going to give a quick demo or walkthrough of the code. You can look more in detail if you're interested. We'll have this posted on a GitHub link that we'll post in the description. First off, this was all the outline of this code was retrieved from tomshardware.com, and it was Caroline, the author was Caroline, who provided this code. So credit goes to her for most of this, large parts of this, and then we built off of it to include, first off we had to train for Joseph's face to be recognized, as well as we had to implement the servo. So lots of things going on here. Here we are just initializing our servo to make sure that it's all locked. This is our wait time for how long the servo waits. And yeah, so here's the hard cascade. Now this was previously given in from the same website, and it's already trained to recognize faces. What we had to do was train it to recognize specifically Joseph's face. And we trained it using another Python script, and that Joseph's face and any of our faces would be included in this encodings.pickle. So then we're getting the input. We have this while loop that's looping through every frame, getting the frame, converting it to grayscale, and doing any other necessary adjustments. It's getting the box dimensions so I can draw a box around the face. So this gives us, using that face recognition XML, it's going to say, okay, here's the faces that I found. So if there's any faces that are recognized, then it's going to loop through all of those. And then it's going to check to see for each of those if there was any matches. from the ones that we had, that we trained. And if true, then it's going to execute all this. And a lot of it is getting the original script just put a name in a box and that said your name. But what we did with it was unlocked a door. And pretty much all we had to add, fortunately, was fairly simple, was just this. So we set the angle of the servo, and then we set it to false, and just printed a message while we're developing, and then and said what time to unlock. As long as there is a face currently being detected, it will stay unlocked, and the timer will keep restarting, keeping set to that 10 seconds left. As soon as it's no longer being detected in this loop, this is the other part. This is what's unlocking the door. So if it's not locked, then we subtract the current time. We subtract the unlock time from our current time and compare it to how long we want it to wait. And then if it's reached that point or beyond, if it's longer than 10 seconds, then we relock the door. Now, future work would include adding a magnetic detection, adding a magnetic strip to know when the door is locked, or not when the door is locked, but when the door is physically closed. So future work would include implementing a magnetic switch and detecting first, is the door closed? If it is, then we can lock it. If not, then you still wait until the door is closed, and then you would lock it, probably a few seconds after. So that is a brief walkthrough of the code and just a little bit of how this project works.
And as I come in, focus, it unlocks. And now after 10 seconds, you'll see it lock again. And there you go.